This was a multi-speed saw, actually 4 speeds. There's a pulley here with 4 steps on it, but when I bought the saw, somebody had already removed the other step pulley for whatever reason, I don't know, and put just a simple pulley on there. And you know, that suits me just fine because I always like to leave it on about the same speed. I'd rather stand there and watch the thing a little bit longer than to run it at too high a speed and ruin a blade and take all the time to change the blade and everything. So since I'm doing more steel than aluminum, I always leave it set at that. I think it's at about 75 feet per minute. I didn't calculate it exactly, but 100 feet per minute is a pretty good universal speed that you can set any saw on and just leave it there. In a high school, you really have to lock everything out because the kids will run it full blast and ruin the blade instantly. Couple safety notes. Make sure you keep that belt guard in position all the time. Wear your safety glasses at all time. I know you guys are sick of hearing this, but we really have to preach safety when we're in the high school and the kids are think that nothing can happen to them. Move the blade guide up close to the work. So if you're cutting small work, this needs to be close to the work, and we do that for 2 reasons. One, so that we have rigidity of the blade, and number 2, we have minimum amount of blade exposed where you might cut yourself. So there's 2 purposes. Now when you raise the saw here, I always put my hand here as I raise it, or there is a handle way up here, but you want to be careful not to grab a saw in this position when you raise it, because the blade is right under there. There is a guard on this saw, but on some of the saws the guards are either missing or damaged or whatever, and you don't want to grab the blade. These machines run very silent as well. One other note, this is a dry saw, meaning there is no coolant. Most of the saws that I've dealt with have built-in coolant systems, but with this one, if it's something that's hard, I just drip a little oil on it, or sometimes use a little water-based coolant in a squirt bottle, and works just fine. I want to tell you several different ways to hold your material now. Sometimes we're going to cut off a piece of material that's fairly short, and it isn't held completely in the vise, if we can get in there. It's held near one end of the vise, and what's going to happen when we tighten the vise is that the vise is going to pinch in on this side, and this movable jaw will become at an angle. So take another piece of material of the same thickness and put it near the other end of the vise, then tighten up your vise, and this jaw cannot swing on you. I'm not sure if we got enough light in there to show you what I mean. Similarly, we're going to cut this piece of tubing in half, and it's a shorty and it isn't held far enough in the vise, so I'm going to block the back end of the vise with one of these jack screws, which I can adjust to any size that I want. And then when we tighten up the vise, it will tighten up against this jack screw. I've got those in several different sizes. I use those on the milling machine as well. They're very handy for that. If you're going to cut a stack of steel, like I've got here, 6 pieces, don't hold it like this, because even though you tighten the vise, there's bound to be 1 or 2 that aren't as tight as the others and will move around and might damage the blade. Always hold a pile of material in there like that. Then we know that they're all tight. Sometimes when we have a big long pile of these, we also weld the end together, the waste stock end. So that's the way you should deal with multiple pieces. If it's round stock, don't try to cut more than 1 piece at a time. In other words, don't put 2 pieces in there like that and cut them, because one will surely come loose. The vise jaws are not that true either. When you're cutting angle iron and just 1 piece, normally we like to put it in there like that, like the roof of a house, rather than like that, where we're now cutting a thin piece that can be rough on the blade. Now if you got multiple pieces of angle iron, this is aluminum. Again, don't put them in like that because one of them is going to be loose. Put them in there like this. Tighten them up. Then we know they're both tight, or you might even have 10 of them that you're cutting at the same time. But that's a good way to hold them. You need to think about how you're holding stock so that you have maximum blade life. Blades are expensive. You want to make them last for a year or more. At all costs, do not cut stock this way, because you're cutting a 1/4 inch stock. It's very hard on the blade, very possible that you knock a tooth off, and then once you knock off one tooth, it's a progressive thing where it gets worse and worse. So lay your stock down flat like that. That'll assure you a squarer cut as well. Now that's a pretty important thing to remember, what I just showed you there. Now, when you're cutting tubing, when you have tubing that is very thin wall, you put that in the vise like such, bring your blade guide up a little closer than what I'm showing there, but feed it very slowly. I'd feed it by hand rather than just let gravity pull it down, because you're cutting thin stock on both sides. You're liable to damage the blade. Sometimes you need, the stock will rotate on you if it's thin tubing, because you are crushing it and distorting it a little bit. So consider that, because once the stock starts rolling on you, it's very easy to damage a blade. Most saws have a set of little brushes, and there were brushes right in here. There's not much left of them, but the idea is to knock the swarf and the chips off of the blade so that the chips don't end up getting wrapped around the wheel. Kalamazoo's and some saws have a nice round brush that rotates. Those are important. Keep those in good condition and good shape so that the chips fall off in this area rather than back into the wheels. Remember that horizontal bandsaw wheels have a flange on them. They do not have rubber tires on like the vertical saws. And you must have the correct width of blade, because the teeth themselves do not touch the wheel, but they hang over the wheel. The flange keeps the blade from being pushed off the top of the wheel. So these wheels are quite a bit different. I'm not able to show them to you on this one very easily. This is also a difficult one to change blades on, so I'm not going to do that. I may do that or show you how to do it on that other one that I have down at the high school. We're cutting 1 1/4 inch brass. Look at the chips come off. And that's running at a relatively slow speed. If I wanted to speed up the blade, I can't do it on this machine, but if you speed up the blade, it'll just fly through material like that. Remember also that blades that have never been used on anything but brass will cut brass much faster. Once they've cut a few pieces of steel, the cutting will not be as fast. You'll notice that very much with hand hacksaws too, and files. So sometimes you should reserve certain blades or files or tools for brass only if you do a lot of brass work. There is an awful big difference. Now this is somewhat warm because we're not using any coolant, but nice cut. Very nice cut. Looks like it's good and square. I'm not going to check it with the square. That concludes the demonstration on this Wells saw. I'll see you down at the high school tomorrow.